Guys, so in this video, fifth video or lesson of Ijama University, and in this video we are going to go in depth and cover solutions 2, and basically we are going to go in depth in the solution area of chemistry, and we are going to focus on that solely. So first of all, let's get started. We know what a solution is. It's basically you dilute a solute and a solvent, and you basically get a solution. It's a physical change, and you can go backwards and forward usually. Now, in solutions 2, we learn about the concentration of solutions, and this is very helpful. The concentration of solutions deals with anything you do in the lab setting to make the solution viable, and to convert the solution into one that is viable in a laboratory testing setup. So first of all, how do we classify concentration of solutions? Well, we can classify it by 3 ways, and these 3 ways include percent solutions, molarity, and molality. It's not on here because it is not. We are not going to cover this as of right now. So ignore this. Worry about percent solutions and molarity first of all. Now we're going to talk about a separate thing called dilution, which is very, very helpful or very critical, especially in a professional lab setting. So you will need to know this to be a chemist. So first of all, we're going to talk about percent solutions. Well, what is a percent solution? It's basically describing the percent of a solute over the total solution, and we can express that by a m over m, which is the mass of the solute, and over, hold on, let me show you. So basically m over m is the mass of the solute, mass of the solute right here, divided by the total mass of the solution, and basically that means the solute plus the solvent, not just the mass of the solvent. So, and then always multiply by 100% to get the percentage, but it's m over m expressed as that, and for the unit wise, you will have to write percent m over m and the name. So as you can see right here in this first example, 7 grams of NaCl in 165 gram total solution. You just put it over each other times 100%. You get this percentage via calculator, and you always have to plug m over m here. Now, as a second way of stating or expressing percent solutions, we can use V over V, which is volume. We're comparing the 2 volumes. Once again, volume of solute over volume of solution. So you can see right here. Let me just move this. But yeah, so volume of solute over total volume solution, solute plus the solvent, as always, multiplied by 100 to get percentage, and express that as V over V. So that's pretty simple, pretty basic. We have one more, which is also known as the same thing as percent by mass right here. They're both known as percent by mass, but this is different in that it is comparing the mass of the solute over the volume of solution. Once again, total solution. So therefore, you're incorporating these 2. You're incorporating this and getting this. And I believe in actuality, in my opinion, I would prefer this because it's very intertwined, if you will. So as you can see right here, m over v, once again, just express that it's the basic units are grams over milliliters and times 100%. So you just can cancel those, and you get a percentage, m over v, NaCl in this case, the solution name. So pretty basic. But then you have the math part down, and all of these 3 ways, dilution, molarity, percent solution, you'll learn the math involved, but also you will learn that there's a lab-wise involved in it, so lab practical. So what would you do to make a solution out of a lab? So as you can see, for in the specific case of a percent solution, so how would you prepare that? How would you prepare, let's say, for example, 100 milliliters of 5% V over V glycerol solutions. Well, first of all, you would want to have a volumetric flask, and let me draw that for you, a volumetric flask. Volumetric flask, and basically it's just a flask that looks like this. You should have this in your chemistry lab, in your school chemistry lab, and it looks like this. Very narrow on the top. This should be narrower, but it's basically like this. Open it in, not this, sorry. But it has a wider area in the bottom compared to the top, and we use this to make concentrations. So, and it's very, very ideal, as shown. But anyways, to prepare 100 milliliters of this, you will first add 5 milliliters of glycerol to the volumetric flask. Ignore that graduated cylinder, but volumetric flask, and add 5 milliliters. And then after that, you will add the water to the flask until the final volume is 100 milliliters. And then you cover the solution and you agitate it, stir it. Yeah, most likely stir it, agitate it, and make sure it's all dissolved, completely dissolved. And that's basically how you make a prepare percent solution. Now, after that, we're going to talk about molarity. Molarity, right here. We're talking about molarity, and basically molarity is stating the amount of concentration in a solution. Once again, it is, the units are moles over liter. So moles over liter, and it's moles of solute over liters of solution. So it's another way to express it. And this one, very important. This one is not a percentage. It's not a percentage. It's a decimal, usually 0.2, 0.02, but not a percentage like this. Not a percentage. And so basically, it's just very similar though, and you can get it very easily. And it's used. This one is used much more widely than this, so I would prefer this over this. So for the math part, it's just moles over liter. You do understand that. And so we're going to describe how to prepare it. How do you prepare 250 milliliter of 0.10 molar Na2SO4? And in order to prepare that, you need a volumetric flask. So basically, you do the math part first. You solve the equation, and you find out that you need 3.55 grams of this. And then you can just balance this out. You should have a stockpile of this, and just take out 3.55 grams, weigh it, make sure it's that, and then you would add that to the base of the volumetric flask. Just pour it in. It should be a solid, and or aqueous. I'm sorry, aqueous. And then after that, you would add water to the flask, but do not add it to the 250 milliliters mark, not yet. So basically, what you do is, I'm gonna draw another flask, but basically, let's say the 250 milliliters mark was right here, and you have this Na2SO4 right here. First of all, you would add water to right here add water to right here, first point. And the total volume should only be about 1/4, so 60 milliliters, or 65 if you will. We don't want to add it all the way yet. And at this point, after you have added 265 milliliters of total solution, you start stirring it and make sure it's all dissolved first. And then after that, you will add water and fill it up to 250 milliliters. I'm sorry, but be careful. Do not overflow, or you will corrupt the concentration, the molar concentration. So be careful with that, and it's pretty basic. And for finally, after all this, we go into dilutions, which is a very important step of converting a highly concentrated material or solution. Highly concentrated solution to a less concentrated solution. So, in a general sense, in a worldly sense, you know that the economy works by efficiency. So, due to efficiency, chemical companies usually produce a stock solution, which is a highly concentrated solution, like 12 molar HCl acid, and it's very concentrated. And hold on a second, I'm going to get to the next video right here, and bear with me. So